Welcome, everybody, to Power BI Time Intelligence Beyond the Basics. Before we get started, just a bit of housekeeping. Yes, the slides and demos will be available, and there's going to be a 15-minute live Q&A session at the end. PASS is an incredible organization that offers a ton of opportunities to help grow your skills and careers. I discovered the organization back in 2009 at a local SQL Server user group here in Atlanta. Through that group, I learned not only a ton about the technologies, but I made some amazing connections that have proven invaluable over the past decade in this industry. So I urge you to explore these. Finally, please take a moment to fill out your session evaluations. These provide feedback to help speakers like me get better, and they also provide feedback to the organizers to help make this event better every time around. So folks, this is how we make the community better. Do your part. Finally, a bit about me. I'm an analysis services and Power BI geek and run a small boutique consulting firm here in Atlanta. It deals mainly with enterprise scale, architecture and design, performance optimizations. So feel free to reach out if you have any questions. What is time intelligence? So this is the point of our session, right? Time intelligence refers to the measurement and analysis of metrics over time. And it's one of, I'd say, the most common forms of analysis in business intelligence solutions today. So if that's not enough of a reason to sit through this session, I'd also argue that learning how to write time intelligence calculations in DAX is perhaps one of the best, most straightforward ways to elevate your DAX game. And simply because it requires you to wrap your head around two very important concepts in the DAX language. And those are evaluation context and filter propagation, which we will certainly be talking about later on. So without further ado, let's dive in. We've got a pretty straightforward agenda here, four main sections. We're going to start off with the basics, date tables, time intelligence functions. This is referring to the built-in DAX ones. And then we're moving into some more intermediate material, some foundational concepts in DAX, evaluation context. We'll also touch on the filter propagation. And then we're going to move into the harder stuff. Now, I don't really mean that in the hard versus easy sense. It's just building upon everything that we've talked about up until then, and it kind of leads into some of the real world hurdles that you'll face when trying to implement time intelligence in your Power BI solutions. So let's get started. The first thing you need to start implementing time intelligence in a Power BI solution is a date table. And there are a lot of ways to create a date table. You can create a date table in DAX using the calendar auto function, although I would advise against this. Both of these functions return a single table with a single column, and that column has a list of date values in it. And then you would add additional calculated columns to enhance it and create a full date table. Things like your month, quarter, year. But again, I don't recommend this. In fact, you can actually do quite a bit of bad things with calendar auto depending on what your data looks like. So calendar auto scans your entire data model, all the tables and columns, and it finds all of the date columns, and then it looks at all those and finds the min date and the max date. And those are your boundaries for the date table that it creates. The problem is that some data sources use special values for dates. For example, unknown dates. They might be January 1st, 1900. Future dates might be December 31st, 9,999. And the problem there is that you get a really large date table, which can bloat your model. It's just not a great idea. You can also create one in Power Query. Here's an example that shows the M language. That's the language you use in Power Query. I think it stands for mashup language. But nevertheless, you can create a date table in Power Query. So this arguably would be better than doing it in DAX as a calculated table. However, you can also do it in your data source typically. So here's just an example of, whenever I'm working with a SQL database that doesn't have a date table for whatever reason, this is typically the script I go to. And then again, this is just showing, kind of the single table with the single column. I would obviously want this to be enhanced to include additional columns such as a month, quarter, year, fiscal groupings, that's sort of stuff. And we're going to see an example of a good date table, obviously, in some of the demos. And now in Power BI, you could actually create it using magic. And I don't really mean magic. I just mean that there are features that you can enable in Power BI that will automatically create date tables. And here's an example showing auto date time for new files. This is a global property as well as a per file property. So if you enable this, what happens is Power BI will create a separate date table for every single date column in your model, right? And so there's a lot of potential um, negative consequences of doing that, especially if you get into the scenarios of those unknown date values or future date values that we discussed earlier. And there's also a lot of limitations here. For example, you can't add additional columns. They only have year, month, quarter, or year, quarter, month, date. So you can't add additional stuff like a fiscal calendar or weeks or that sort of stuff, right? And you also can't rename the columns. You're stuck with, what they give you. So again, I advise against this, and I would suggest, ideally putting your date table in the source so that it can be reused in all of your Power BI solutions. Okay, let's jump into our first demo. I'm going to go ahead and exit out of this and switch over to my demo machine. And what we're looking at here is a pretty standard model. I've got an internet sales transaction table, and I have two dimensions hanging off of it, a customer table and a product table, right? And this, let's look at the report, but this particular solution does have the auto date time enabled. And we know that because if we come over here and look at this field explorer, I can see this little calendar icon by all of the date columns in my internet sales transaction table, right? And this enables me to have access to a hierarchy of year, quarter, month, and day, which is what you see here in this matrix. So here we're seeing sales amount grouped by these various levels. These don't exist in my internet sales transaction table. They're created out of thin air, okay? And this is because I have the auto date time enabled. So if we come over here to options and settings, let me show you how to turn this off because we don't want to use this. So here we see at the global level in the data load section, we have this time intelligence, auto date time for new files. This is unchecked because again, I don't recommend this. But for this particular file, I've enabled it at the file level. So here are the global settings. Here's for the current file. Both of them have data loads. And in this case, I'm going to go ahead and turn this off. And so once I hit OK, we should see all this disappear and I'd be back to just my date columns in this sales table. And so before I jump into that, I kind of want to just belabor like why that's such a bad thing. Because again, if you have those special columns, the unknown of January 1st, 1900, and the future date of December 31st, 9999, you end up with a super bloated model. So here's an example. This is Vertipack Analyzer, and it's part of DAX Studio. Both of these are just amazing tools, so highly recommend. But here we see that I have a Power BI file that's almost a gig. It's not this one. In fact, it's actually this one over here. This is just an example. We have a single table with 4 columns, right? This table only has 2 rows, right? But if you look at what's in these rows, these are date time columns, or sorry, date columns, and we have January 1st, 1900 and December 31st, 9999, right? What happens is it's creating all of these date tables. If you look over here, these are the tables behind the scenes that get created. Oops. Okay. And so this is just a great gross example of what can go wrong. So just be very careful if you do intend to use these. By the way, the same thing can happen with your auto date time, or sorry, with your calendar auto if you create a DAX date table. So let me close this and get rid of it. And let's go back to our original solution. So I disabled the auto date time. Our matrix goes back down to the date because that's the only true column we have in this table, right? And so let's just go back and look at our model now. So let's look at the full model. And here we do have a date table. I just had it hidden. And you can see there's quite a bit of columns in here. And in fact, what you'll see, one characteristic I think of a good date table is one where there are more hidden columns than exposed columns. And that's because what you'll end up with is there are only a few, well, I shouldn't say a few, there could be quite a few columns that the users will actually drag out onto the report to create, visuals. The rest of them, the vast majority, will typically be these little helper columns like date sequence, sequence of month. Um, these are going to be used behind the scenes in DAX calculations, right? Because though, as we'll see once we get into some DAX, these make it a lot easier to do this sort of to implement the sort of logic that you're going to be asked to implement in a real world solution. So now that we've unhidden this, we can come back to our report and we can change this up. So now order date, we no longer need to get that from our transaction table. We can come over here to our date table and let me just throw out year and then quarter. So we can reproduce what we just saw using our own date table. And this is typically the preferred method. Another thing that's really cool about these is if you've ever had to, and because this is a common request, have you ever had to create a Power BI report or dashboard that automatically updates to the current period, right? You've got a couple of options, right? One is to use the relative um, date configuration of the slicer. So if you put a date out here we have order date from the transaction table. And I have an option here in the drop down. I can change the type of slicer. So a lot of times, it just defaults to a between, but you can actually go relative date and you can say last 1 year or last day or, this day, right? But the thing I'd, urge you to consider is that there are some limitations here. And a lot of that has to do with the fact that this is based on the concept of relative date being relative to 2-day UTC. So you have to get a little creative here with how you configure this. Personally, I like to control it a little more. So instead of using something like this, I would use my own relative date filters that get populated with some logic to them. Sometimes today or the current date is actually yesterday or the last time the ETL ran, right? That's what the business considers today and from a reporting perspective. Okay, so we can accomplish the same thing here, and I'll just show you a quick example. Let's create a new page, and I'll throw out date on my axis and then sales amount. And our values, and if we look at this, right, so we see sales amount by time, but if I wanted this to only report the current year to date, I could throw this out here. This is a current year to date. So this is a column in my date table, and it has a 1 for every date, every row that falls within the current year to date, right? So if I check this, we see that the current year to date, according to the data that's been loaded here, it thinks that the current date is September 10th, right? So we have of 2013, right? And this is dynamic, right? So there's logic behind this. So if I refresh this, or so let's just say I publish this to Power BI, the service, and then I configure the scheduled refresh. Well, every time it refreshes, this gets updated. Additional rows are added. So we saw that, currently, and the last time this file was loaded, September 10th, 2013. If we refresh, so we'll simulate a scheduled refresh, there's dynamic logic used to populate these. And loading, loading, loading. I probably could have gotten away with just loading the date table. But we should see this change, and we should see now, yep, there, it grew a bit. So now we're all the way to October 23rd, right? And so that would happen. And then tomorrow, when the schedule refresh kicks off, this chart or anything else configured with this filter would update. And so this is just an easy way to accomplish this, and it allows you to apply a good bit of control here, because this could be current fiscal year, this could be current custom whatever, okay? All right, so let's switch back to our slides, and we're gonna sum up some key points and then move on to the next section. Okay, so helper columns. This is probably one of the biggest ones about having your own date table. Right, here's just a couple of examples. I'm not going to go into the details. Text is small on purpose, and this is by no means comprehensive. You know, you should come up with ones that are specific to the types of analysis you need to perform. And don't think just about the current solution that you're building. Think more generally for maybe the current solutions that your company might need to build. So the closer you can get to a standard date table that is used across the company, the better, right? Because that's better for the developers. It's also better for the user experience that gets created in these solutions, right? And then here we talked about the relative date slicers. Again, one of the main drawbacks here, besides the limited functionality, is the fact that it's all hinged around UTC time, which might not necessarily work for everybody. Okay, so our key points here, right? I might not have mentioned this, but having a date table is required for the time intelligence functions to work, and we're going to get into those in the next section. Time actually needs to be in a separate table. Your date table should only have one row per day, right? And you should also have it complete calendars, years. So don't have something like March 15th, you know, be the first date in your calendar. Always start with a January and end with a December 31st. Okay. Mark as date table. This used to be required for everything, but now if you are joining tables, your transaction tables to your date table on a date column, this isn't actually necessary. But if you're using some of the more traditional data warehousing techniques of using an integer surrogate key for your date table and your transaction table, then you do need to go mark as date table. And again, helper columns make everything easy, standardize, centralize, reuse. Might be a good use case for data flows depending on what your ETL platform is. And please do not use the auto date time. And I say don't use the calendar auto. I don't like it, but just be careful if you use it. All right, let's get into some DAX. So time intelligence functions in DAX, there are quite a few of them, right? If you ever want to know how these work, I suggest going to dax.guide for the intricate details. It's got basically the same information as the Microsoft documentation, but it also has helpful links to articles written by SQL BI guys that go into depth about how to appropriately use some of these functions. And they even have an entire section dedicated to time intelligence functions. So again, great resource. We're not going to cover all of these time intelligence functions, but I am going to show you a few of them and then also how to debug them. So a bit more. So time intelligence functions, there are a ton of them. They all require a date table. And they support days, months, quarters, and years, right? I'm calling that out because they do not support weeks, semesters. They don't actually support time, hours, minutes, seconds. And then there's also limited support for fiscal calendars. So I want to bring that up because you know, several of the functions do have a parameter that you can use to specify the last date of a fiscal year. However, there's some limitations there, such as the first day of the fiscal year must always be on the same day for every year. Well, that's not necessarily going to hold up to all fiscal calendars. It might hold up to many, but not all. The start can't be the 1st of March. Apparently, there's some sort of bug there. And then quarters always have to start on the 1st of January, April, July, and October. And again, that's not necessarily going to hold true for all fiscal calendars by all organizations, right? But the biggest one to keep in mind is that you're going to require some customization to meet the business requirements for a lot of real world scenarios. A lot of this can be defensively protecting against, you know, future and historical boundaries, as well as ensuring you're comparing apples to apples when comparing a current period to a prior period. So we definitely get into that in the last section. Let's jump into some demos. So I'll switch over to my demo machine, and here we have a Power BI solution waiting for us. All right, so what we're looking at here is a matrix with year, months on rows, and the sales amount in our values. And so let's go ahead and write a DAX calculation for year to date. And we have a couple of ways to do this. So let me get this loaded up and increase the font size a little bit so everybody can see. And we'll call this sales amount year to date. And we have a DAX function to do total year to date. So all I have to do here is say, well, what do I want to total year to date? I want to do my sales amount measure. And sales amount measure, again, is just a simple sum of the sales amount column in our internet sales table. And then I specified the date column of my date table, and that's all I have to do. So let's go ahead and format this. Come on. Still thinking about it. There we go. And let me make this a little wider. Throw that out there. Oops. Throw that into the existing matrix. Okay, and so now we see at the year level, these match, but if we dig into a lower level, we see here we have just the monthly sales amount, and then here we have the running total, right? So not too terribly difficult. All right, so let's do it another way, because we have a whole bunch of options on how to write these. And in fact, some of them have two functions for a very similar purpose. So we can write another way, sales amount year to date V2. And this way, we can actually use the calculate function, and we're going to calculate sales amount, but we want to do it in the context of the year to date. So dates year to date is a function here. And I'll just get this typed out. So we, as I mentioned, right, you need to have a date table, but also the key column in your date table is the date column. It doesn't have to be named date, but it does have to be date, time. And this is an input to almost all, actually all of the built-in DAX time intelligence functions, right? So if you're not familiar with Calculate, unfortunately, we don't have enough time to really dive into the guts of it, but what it does is it allows you to change the context before doing a calculation. And so in this case, I'm saying I want to calculate sales amount, but first I want to change the context to be all the dates for the current year to date. And so we can write it this way, and it'll produce the same results as the first version. Right, so here we see these values are the same. Okay, good stuff. All right, so let's move on. Next, another common one is to do the prior year, right? So we can do a year-over-year comparison. And so here we have that same matrix, and let's write a prior year measure. So I'll call this sales amount PY. And in this case, I don't have a prior year, like the totals year to date, but I can do this calculate again. And I can say I want to calculate the sales amount, but I want to do it for the previous year. And so here's another time intelligence function. Oops. Let me specify the column here. And that's all we have to do. Calculate sales amount in the context of the previous year. All right, so let's go ahead and format that and throw it out there in our matrix. All right, so here we can actually see 2011, but we do see that 2012 was 5.8 million, and then so the prior year for 2013 shows 5.8 million. Good stuff. Only one problem here, right? And the problem is that this is only going to work at the year level. So if we see the growth here, we grew significantly. We tripled in size. And so, but if we look down here, we see that we have the sales amount at the year level repeating down at the month level. So if we tried to do a year over year comparison, this would show incorrectly. This would show us that we're just getting crushed every month, right? So this is wrong. So the thing to note here is that the previous year function only works at the year level, right? So to work at the monthly level, we need to write another calculation. And I bet you could probably guess how this one's going to change. I'm going to copy the previous year one and say previous month. And all I have to do is change this from previous year to previous month. So let's add that measure in, and we'll format it. And throw it into our matrix. And we can see, okay, great. So now we are getting true monthly values, right? But we have a bit of an issue here. So at the year level, the year version, the prior year version is correct, but the prior month version is incorrect. And in fact, this is actually the prior month of you can see it right here. It's December 2012, right? So not necessarily a good idea because you want to create a prior period calculation, right? But you want users to be able to dynamically zoom up and down or drill up and down of your matrix. And this could also, just as easily be a graph with sales amounts being graphed over time, where we have year month hierarchy on our x-axis, right? And so being able to drill up and down, you know, we would need to switch the measure. So we'll come back to that problem. But I want to show you right here how I know, besides just looking at the number, how I know that this is the year level, because we have the ability to create debug measures, and this will come back to prove very useful. So I'm just going to expand this out a bit, and let me actually not do that. Let's go ahead and write our debug measure. So we know that, right here at 2012, I expect this to be January 1st, 2012 through December 31st, 2012, right? And I can confirm that with a debug measure, which I'm just going to call date debug, and I'm going to copy it over here. And all we're doing is, oops, we're formatting, right? So the first part of this is just saying, give me the min date that's in context, format it like this, and then it's creating a string. And then on this side, it's the max date. So this is a from what date to what date is in the current context. And this is how we debug a lot of time intelligence. So I'll throw this out here to our matrix, and we can see that, okay, so at the year level, right, I am getting January 1st, 2012 to December 31st, 2012. And then at the month level for January, I'm getting January 1st to January 31st, February 1st to the 29th, so it's a leap year. But to see what's happening for my prior month and prior year, I can write additional debug measures. So I can write a date debug prior year. And I do it the same way I wrote the time intelligence calculation for prior year. So in this case, though, I am calculating the date debug measure, and then I'm doing it in the context of the previous year. So this is the same format as the original calculation. And so, forgot to add the column here. And so once that's ready, zoom out over here and throw this one in. Right, okay. So if we can remove that, there we go. So here is our, let me just come out way out here. Oh, that's not helpful. So here we see our original and we see the month breakdown, but here at the month level, we're still getting the full year. So that just further confirms that the prior year or the previous year DAX function only works at the year level, right? And so we'll talk about how to solve this in another demo. But I want to say this because this is a common stumbling block, is folks trying to create prior period calculations and use them dynamically in visuals to drill up and down. And so a lot of times they're discouraged and they end up using, moving over to a different calculation, which is same period last year. All right, so I'll show you this one real quick too. So if we have new measure, and we'll call this same sales amount, same period last year, sales amount. I'll just abbreviate it SPLY, but it uses the same format. Calculate some metric, in this case sales amount, and then do it, but for the same period last year. And that's all there is to it. So let me show you how this one works. throw that out in our matrix and format it. Okay, so here we can see that, yes, it is working at the year level. And let's go ahead and zoom these in. Okay, and if we look at the month level, it does look like we have month values. We can confirm that by expanding the previous year. So here, January of 2012, we did $495,000. The prior year, January, we did 469,000, and we can confirm that is indeed correct, right? So this works, and in fact, it does work. It works at all levels of the hierarchy, so even down to date, which is why a lot of people do just move to this calculation simply because it's easier, and you don't have to deal with the issues we ran into with the prior period calculation. Right? So let's switch back to our slides real quick and run through a couple more items just to refresh what we've discussed. So we saw the total year to date, and we saw that there were two ways to calculate this. And here's an example of how that's actually working. And then this, again, this is a total month to date, and I believe there's now quarter to date that wasn't there before. So yeah, we have a lot of options here, and then the format's, fairly similar, right? But we do run into this issue here, having a total month to date at a year level, similar to how we had an issue with the previous year at the month level and the previous month at the year level. You have these sort of issues that need to be addressed. Okay, and here's the previous year example. As we see, it's repeating at the month level because it doesn't work at the month level, right? And then previous month, yeah, doesn't work at the year level. Right? And then we saw some debugging approach, right? So here's a good one. Soak this one in. This is very reusable. And then the way to actually take this debug measure is to just compute it like you would whatever time intelligence you're actually doing. Right? It's just debugging. It's displaying a string that shows the range of dates and context. Right? And then we showed you the same period last year, which is what most people move to when they struggle with the prior period calculation. Right? So prior period is slightly different, right? So we're talking about at the levels below the year, we're not talking about the same quarter last year. We're talking about the adjacent previous quarter, right? And so there's a difference there. And sometimes business logic calls for that, right? It really just depends on your organization. Sometimes you don't want to compare with the following year. You simply just want to compare with the previous year to see how growth is trending within the current year. Right, so here's another just slide to highlight the difference between these two. So let's go back and I'll show you how to solve the prior period calculation. We can combine these into a single measure. All right, so back over to the demo machine. And we can get rid of this now. And we'll come over here. And so we already looked at the prior year calculation. And this works at the year level. This is using previous year. This one's using previous quarter, and because we have, year quarter on rows, this totally works, and we don't have to worry about drilling down. These are static though, right? And then previous month works as well. But what we want is it to be more dynamic. We want to be able to create a visual on our report that users can drill down and drill up with a single calculation that adjusts accordingly. So to do that, let me go ahead and expand these. We can create a single measure that references. And I'm going to go ahead and just start writing it, and then we can discuss what's happening. So let me make this a bit larger. Okay, we'll call this sales amount prior period. I'm going to make a bit of room here. So first thing we need to do is start with a switch because we need to test conditions. And so this format basically just says, enter into a switch, and then go through these logical tests one by one and stop at the first one that returns true. So in this case, we have another function that says is in scope. And I can say is in scope, date, is the month in scope? And if so, if that's true, then calculate that or return or evaluate that calculation. Or if that's false, it comes down here to the next one. and we test for quarter. And if that returns true, we want to evaluate the prior quarter logic. And then is in scope year. Keyboard, there we go. And if so, return the prior year. And if none of them are in scope, don't return anything. Right? So that's pretty straightforward how that works. And is in scope, this is available in Power BI and Azure Analysis Services, I think also in Analysis Services 2019. But before that, and if you're not using that, if you're using an older version, you had to do it a different way. And it was the has one value is another function. And I've got a slide in there with a link that explains the difference between the two. But for what we're doing here, this is probably the preferred approach. Okay, so let's get that out of here. And now we'll throw that into our matrix. We're going to collapse everything. Oops. There we go. Okay, so we can see at the year level, oh, let me a little bit of formatting, make this easier on the eyes. Okay, so at the year level, we can see that, yes, it is working. This is returning the previous year's value. And then we can go down to the quarter level. And we see that, yes, this is returning the previous quarter, right? So quarter two, previous quarter is returning quarter one, and quarter one, previous quarter is returning quarter four of the previous year, right? So these two, right? So we see that that's correct. And then we can go down to the month level, and we see the same thing. So February, we're returning January's amount, and then January is returning December's amount. Right? So we see that those are equal. So we see this is working at all levels, and that's fantastic, right? And all we had to really do is just simply logically check what level are we at, and then return the corresponding value. So let's switch back to our slides. Okay, like I said, here's a slide that explains the difference between the is-in-scope function versus the previous way of doing this, which was the if has one value. This link right here by the guys over at SQL BI is very helpful. It explains with demonstration on why these two are different. All right, evaluation context. So here's where we start. We just kind of hit pause a little bit and let's build some foundational knowledge. Right, so evaluation context refers to the context in which a DAX expression is evaluated. Now that sounds a bit like wordsmithing, so perhaps an easier way to explain this is with a matrix visual. Right, so here we have a basic matrix with year and month columns from our date table on the rows of this matrix, and then we have the sales amount measure in the values. Right? So each cell in the value section of the matrix has a context. Right? So this first row here has a context of year equals 2010. Second row has a context of year equals 2011. And then the fourth row here has a context of year equals 2012 and month equals January. Right? And this sales amount measure is being evaluated in each cell in this value section, right, based on the specific context of that cell. So let's dive a little bit deeper and look at the data model because we need to understand the data model to really explain what's happening here. So if this is our data model, right, where there is a date table and a sales table and a regular one-to-many relationship between the two, then the previous highlighted cell for that row 4 here, right, you can see this in the upper right, that is calculated as follows, right? So first we want to filter the date table for only the rows that fall within January 2012. Next, we want to propagate that filter from the date table down to the sales table, right? And that's because of this relationship here. And so this little arrow tells you the direction that the filter propagates, right? And so this arrow is pointing at the sales table, and that means the filter will propagate to the sales table. Okay? And then at this point, the sales table is filtered to only include rows with an order date in January 2012, right? This is, again, called filter propagation, right? Key concept. And then finally, we take the values there and we sum them up. And that's how we arrive at that value. Okay? And this is a very, this filter propagation is a very powerful concept And it's also why dimensional modeling is still the gold standard for Power BI and semantic layer solutions. Right, so here we have an example with multiple fact tables, transaction tables. On the left, we have our inventory table. On the right, we have a sales table. And then both of these are related to our date dimension table, right? So that's just star schema, dimensional modeling speak. But in Power BI land, you could just say there's tables and there's directed relationships between them, right? And the cool thing here is that this just automatically happens. So if we want to apply a filter for January 1st, 2012, well, that filter is going to propagate to our sales table, and it's also going to propagate to our inventory table. And so we can figure out what are these values. So if we put date on rows of a matrix and then we pop out our measures in the value section, that's how these are calculated. Right? So how does this apply to time intelligence? Well, easy. First, for time intelligence, we have to detect the current context. Right? Next, we need to create a new context, and then finally, we calculate some metric within that new context. Right? So all time intelligence can be broken down into these three steps. Right? So this is some foundational understanding here. So take this in. Right? So in Power BI, current context can originate from a couple of different places. Right? We can have filters applied from the filter pane of our report. We can have slicers on the report canvas. We can have cross filtering from other visuals, and then also just the columns or the breakpoints on our visual. So here the x-axis creates a context. So that's 2011 sales amount being showed there. So there's a context being created for the year 2011. Okay. So in dealing with this context, detecting that current context, we have a couple of functions to use. Min and max are a very common one. There's also selected values, so we'll see some examples of these, right? But this is the same sort of work that we're doing here in this debugging function. We're grabbing the current context, the min date in the current context, and then we're just displaying that. So the min and the max, and display that, and that gives us our range. So we're going to do something very similar like that in these upcoming demos. So let's dive into our conquering context demo. Bring up my VM. Okay. So we've already solved a previous year. We saw kind of the issues with this previous year function. So let me bring this up just to refresh everybody's memory. So if I show you here, we've got, right, we calculate sales amount, but we want to do that within the context of the previous year. And we know the downfall of this, right? It only works on years, but we're going to just kind of ignore that for now. We do know how to solve that. But let me show you another way we can write this calculation. We can do it in the three steps that we saw on the slide. So let's call this sales amount prior year, V2. And the first thing we need to do is we need to capture the current year, right? Because we need to know what the current year is so that we can go back to the previous year. So current context year equals, and here I can say, I can use max, I can say selected value. Well, let's do selected value and year, right? And so what this does is like on this row, this function returns 2013. On this row, it returns 2012, right? And that gets stored as a static value in that variable. Next, we need to create a new context. And so I'll just type this out, but this is our dates prior year. And to create our new context, we need to first, remove all filters from the date table. And then we can apply a new one. So here I can say date, year, and since we're doing prior year, I want to do current year -1. Okay, so let's talk about what's happening here, right? So we want to filter, but before we filter, we need to remove existing filters on the date table because on the current row, this date table is already filtered for a specific year, the current year. And we remove that filter, and then we apply a new filter using a little bit of easy arithmetic, right? We just take the current year and we subtract 1, and that gives us the prior year. And so now that we have that new filter context, and so this shows the power of variables, right? Because this variable is holding a static value. This variable is holding a context. Now, that's a very fundamental understanding here. We're going to gloss over it because that's a very advanced kind of concept. But just know that we can do this because this pattern is the same for all time intelligence, as we'll see. So our return value, and all we need to do is calculate something, and we want to do that in the scope of our, in the context of our new prior year. And then we can just return our ret val. Very straightforward. I'm going to copy this because we're going to reuse that in the next example. I'm going to throw this out there, and ignoring the decimal places, it's doing the same thing, right? And it also, granted, it also has the same issues as this one because we don't do anything to account for the month level, okay? So let's move on and let's do a year to date, right? So here we've got a year to date, and here's what our original year to date is. It's a pretty straightforward function. And let's just show how we would write that in the extended version. So I'm just going to jumpstart this, and we'll just call this year to date v2. And here, I need a little bit more information. So in this case, I need to get the max date. So the max date of the current context, right? So if we're on the row of the matrix that says 2012, right, the max date in that context is actually going to be December 31st, 2012. So I need to grab that and do this. All right, so I've got that value. Here, year, I also need the year value. I could do it this way. I could also just go year because this is a date value, so I can grab the year of the date, right? Same way. Sometimes this is easier to do, especially for some of the other time intelligence logic. And then we're going to call this one dates year to date. And so again, we remove all filters on our date table, and then we reapply to get our new context, our year to date context. And so in this case, I don't need to go back a year. I need to stay with the same year. And then I also need to apply another filter where the date is less than or equal to the max date, right? So again, this is just year to date logic, right? And then once I have that, I can calculate my ret val in that new context, and voila. Okay, so let's back out of here. And these are my dogs. Right, and we can see that this is providing the same values, right, year to date. We've got a running total minus the extra decimal places. All right, so you're probably wondering why on earth would we want to write our calculation like this when we could just as easily write it in 2 lines, 3 lines of code? And really the answer come in the next section. So conquering context, right? Again, just to reiterate, all time intelligence patterns can be broken down into these 3 steps, right? We capture the current context, we create a new context, or we modify the existing context, and that's what that filter all. And then we calculate our whatever measure we're doing within that new context. Okay, at this point, it's time to build on everything we've learned up until now and start tackling some of the common challenges and obstacles we're going to face building real-world solutions. And so here's what I mean by challenges and obstacles, right? What about time periods, that aren't supported by the DAX time intelligence functions? For example, weeks or semesters, right? And then we have boundary detection and protection. How do we handle a scenario, where we need to calculate a 6-month moving average, but we're at the beginning of our data set and we only have 4 months of historical data for that current period, right? And then we have an incomplete or current periods of different size issues, right? For example, how do we handle the scenario where we need to compare the current month, which may not be complete, with the prior month? Comparing a full month with a partial month is a form of analysis. How are we trending towards last month's sales? But if we're just comparing it month over month, it's a bit of a apples and oranges scenario, and it's going to give you incorrect guidance until that very last day of the month. And then we have, non-standard or custom calendars. We've got 445s. We've got really weird fiscal calendars in some organizations that are non-standard, right? These are impossible to solve with just the built-in time intelligence DAX functions. So these are just a few of the challenges that we'll inevitably encounter, and they require additional logic above and beyond what's available in the DAX time intelligence functions, right? So to properly meet our requirements. So instead of just kind of talking about these, let's just dive in. And I'm going to start with kind of a completed solution. And we're just going to walk through this due to the time constraints we have right now. So let's say we're tasked with a week over week, right? So we can simulate a prior week calculation. Let me show you what that looks like. And zoom in a little bit. So here, we're using the same kind of pattern. We're detecting our current context, we're creating a new context, and then we're calculating our metric within that new context. The trick here, though, is that I've got a helper column in my date table called week sequence. And this is just a numerical index. It starts with 1 in the first week of the first year of my calendar, and it continues to increment for each subsequent week. Right? And it doesn't reset at the end of a year, right? It just continues to increment, right? And this allows me to have very simple date arithmetic to calculate a prior week, right? So we can see that this is in fact working here. 78,000 would be the last week of 2012, right? And then for week 2, we see the prior week showing the same value as week 1. So this is working, except down here. So here we get to week 38, which is the last week that we have data. In this data set, today is considered September 21st. And so for week 39, we don't have any current data. So we probably shouldn't display anything here. So we need to protect against that. And we can do that by using our version 2. Let's throw that out there. And version 2 matches everything and it hides the end. So let's look at how we achieved that, right? So this is everything you just saw with the exception of we are calculating some additional contextual information, right? So we also get the minimum date for this range, right? And this is the same min date that we used in our date debug function. And then we get today. And notice that I have a special column in my date table called today, and it has the same value for every row in that table, and it's populated with some logic, right? Because it's not just today, as in today being December 23rd, date of this recording. No, it's not that non-deterministic today function, nor is it the SQL get date function. This is created with ETL logic. So I can control what today really means in my data set, right? And then everything else after that is the same until we get to this return statement. And then we just have a conditional check to see if today is greater than the min date of our context, meaning do we have data here? And if so, return a value or the calculated value. Otherwise, return blank. Right? So that's pretty straightforward. So the cool thing here, though, is I'd say the week sequence, and then the rest of this is just defensive programming and checking your boundary. And so this week sequence, again, a helper column, lends itself to other calculations too. So we can do rolling averages with this. And so this would work the same way, even at a month level, where we would have a month sequence in our date table. Right, and so here we calculate a rolling average. Let me go ahead and show you what that looks like. We got our rolling average. So it's all the same, right? This is just what we saw, and then we have these two additionals for the boundary protection. But here we calculate our dates for the 4 weeks that we need to average, right? And here we have our week sequence is greater than the current week, subtract 3. So this is just a range filter, right? And then we take this context and we calculate our sales amount. So what are the sales for the last 4 weeks? And then we just divide by a fixed 4, because this is a 4-week rolling average. And you can get real fancy with something like this and use like a what if scenario or some sort of disconnected table and change this. So you can parameterize something like that and this. So you can do like a sales amount in week rolling average with a control from another slicer. But we're not going to get into that. The one thing I do want to show you about this, because it looks like it's calculating correctly, the only problem though is that some of these numbers look a little small, right? So Here we have, about 110,000 on average. But, here we see that this is really slipping. This is way too small. And the problem is that our data set stops right here. So at the second week of the entire data set, we can't calculate a 4-week rolling average, right? Because we don't have 4 weeks to average out. And so we're actually taking two weeks of data and dividing it by 4, which is giving us a bad result, right? And so let's throw out what that 4-week rolling average, because this one has a fix. Oops. Let me add this to my matrix, and I'll show you how we handle this. Thinking about it, right? And so really we're just blanking it out, right? Because this only has 4 weeks, and these are very small weeks here, so that's why this number is low. This has 4 weeks, but all of these here, the third, second, and first week, don't have 4 weeks, so we can't calculate it. And we simply just hide it. So what does that look like in DAX? Well, it's a bit more complicated here. So if we look at this part, this is all the same. And then we're calculating our 4 weeks range. But what we're doing is we're adding in an additional logic here. So we're saying, yeah, go ahead and filter this date table for this range, but also exclude any dates that happen before our first order date. And so this is just a measure that returns the date value of the first date that exists in our internet sales table. So I've got this on a card right over here. Let me show you here. So our first order date is 12/29, right? So that just blocks us from including too many weeks. So when we look at this, what we're doing is we're taking this filter and then we're calculating the distinct number of week sequences we have in that filter. And we're saying, does it equal 4? And if it equals 4, then this is true, right? This is the same right here as our original rolling 4-week average, but we just add this to our final conditional check. So making sure that it's not a future date, and then also making sure that we truly have 4 weeks in our range. And if both of those are true, then we're going to return the value. Otherwise, we're going to return blank. Okay? So again, this gets a little more complicated, right? As you can see. And so, just something to keep in mind when you're writing time intelligence. So let's look at another common one, and this is the incomplete period problem. Okay, so in this case, we have our sales amount, and then we have our sales amount same period last year. Okay, so September, we have almost $1 million, and we have about almost $500,000 for the prior year. We also need to hide this, so we can do that with boundary protection, which we did in V2. Right? But this is still wrong. And the reason it's wrong is because in this data set, today is 9/21, right? So September is not complete. But this represents a complete September from 2012, right? So we need to adjust that. And there are a number of ways to do this. But one way that we've done in step 3, and let's go ahead and show this because this is a bit involved, is to recalculate our range. So here I'm doing the same thing. I'm taking the min and max date of the context, of the current context. In this case, it would be September 2013. So this would return the first date of September and the last date of September. And then I have my today for my future boundary protection. But I don't just want to filter for this range in the last year. I need to do a quick check. So my range start, my new range start is always going to be this min date. But my max date, if it's the current period, then my max date is going to be greater than today, right? So max date would be September 31st. Today is actually 9/21. And so this returns false. And so it puts today as my boundary. So what I end up with here is I remove all the filters on the date and I reapply a new range filter for September 1st, 2013 through September 21st, 2013, right? And then I do something real crazy. I use that context to calculate the same period last year. So instead of calculate, I'm using calculate table because I want to return a date context and capture it in this variable. And so I can do same period last year, and then I can calculate that in this new context. So what this returns is September 1st, 2012, the prior year, through September 21st, 2012, the prior year, right? So this gives me a true apples to apples comparison. And we can see that here. If you expand this, so because of the way this is written, both of these stop on the 20th, okay? But at the month level, 331,000 is the sum of these numbers. Even though these aren't displaying the future values, they are contained here in this month level, right? So this, again, it's quite a bit of logic that has to be added surrounding some of the built-in time intelligence functions just to adequately handle boundary conditions and ensuring current apples to apples comparison, right? So it's not as straightforward as just using out-of-the-box DAX functions. Okay, so let's switch back over to our slides and we'll just run through the rest of this stuff real quick. Yep, so again, just noting the value of our helper columns, we see that this is a numerical index that increments for each week. We checked some boundaries, right, using today, and note that I had a special column called today in the date table. And then comparing incomplete periods here. So this is what we're truly going for. And we want to make sure that we are comparing apples to apples. Even though this looks correct, 963,000 to 486,000, it is not correct. We should be comparing this number to this. So even though we're doing well, we could be doing better. And that's one of the tricky things about writing complex DAX calculations is that sometimes you get results that look reasonable, right? And then that's just not enough. You really need to understand what's happening. And to do that, you can break down and use some debug functions, right? So that's all we have for material, but I have some additional references here that I want to quickly run through. I'm a book person when it comes to learning. I know there's a lot of good video sources. I would like to recommend these books. So if you thought the material in the session was pretty complex, then you probably want to start with this first one, Beginning DAX with Power BI. If you understood what you saw, but you think you'd have trouble reproducing it from scratch, then you're probably somewhere right here in this second book. Both of these are excellent books by Phil Seamark. I like the way he words some of these concepts. And then everybody will ultimately want to pick up a copy of this definitive guide to DAX, right? I've also got some links on the right-hand side. These are pretty much complementary to what we saw, right? DAX Patterns is a great website. They have time patterns, right, that goes through a lot of these scenarios that we talked about and shows you ways to solve them. Calculation groups and tabular editor, these two go hand in hand. So once you do get your time intelligence logic written and you've got all your edge cases handled, then you can just kind of replicate them out with calculation groups. You don't have to rewrite them for every metric, okay? All right, so thank you everyone. The demos are going to be posted here to this GitHub. Here's my contact information. If you need anything, have any questions, please don't be a stranger. And then one brief reminder, please fill out your session evaluation. Let's make this community better, and this is one way to do it. Thank you.